So it's 2024 and AI has been popular for quite a while. But what about its foundations, such as, for example, machine learning? Why are we always using, or let's say most of us, some kind of cloud services such as ChatGPT or, I don't know, Google's Gemini, while we can actually build, in a way, fine-tune our own machine learning model on our own local machine and use it without paying any, let's say, costs on subscriptions. So how to do that? In this video, I would like to show you how to fine-tune a machine learning model with FastAI wrapper. And also it will be based on the practical deep learning course for coders, which you can find here. I will actually link all of those, let's say, courses and materials under this video. In this video, I will show you how to actually fine-tune a pre-trained machine learning model with this library in Python. So let's get started. First of all, what we will need is, of course, open some kind of new folder, your favorite coding editor, and also be sure that you have a Python installed on your machine. In my case, it was actually Python 3.11.6. And actually that's all what you will need. You will have to create most likely the virtual environment for Python. So like you can see in this case, I have this env. I'm already in the Python virtual environment. And of course, install some libraries. In our case, we will install two libraries. So we'll need, we will just execute, let's say, command pip. In my case, it's free because of the executables, install and FastAI, as well as duck-go-search for, let's say, searching for new images on the internet and creating our training and validation data. So after installing those two libraries, we should be good to go. Next, what you can do is just create a main.py file, but you can name it as you want. We will only need one Python file, and we can just start importing the libraries at the top of the file. And as you can see, we can just follow along with this article. What you can see here, all of the comments are here. So after installing this libraries, we can just copy this libraries. As you can see, we have this DuckDuckGo search and fast download for downloading URLs, as well as some core libraries, including the FastAI methods that we will use soon. And first of all, what you can see here, we have the search method. So let's just import it down below. So what is the search images function? Actually, we'll use this function to call our DuckDuckGo search, and we will, as you can see, accept two arguments. In this case, it will be keywords and max images. This is just like it is kind of optional, so in case we don't pass anything, we will have maximum images of 30. Otherwise, we can just decrease it or increase this number, and it will return us the list of the links to various, let's say, images. How can we just verify it? As you can see here, what you can do is just copy this under this function. Don't forget about indentation, as we are in the Python this time. So as you can see here, we have this dog photo URL. We are executing it via this function actually. So we are just searching for the dog photo and max images to 1, as we will only want one picture. And as you can see here also, we are, let's say, extracting the first element out of this list and printing the link. So if now I run this file with the command python and main.py, just save the file first of all and then execute it. As you can see now, we can see it logged, so it was searching for dog photo, and we have this link. You can also just click the link to verify does it work or not. So once we have it verified, we can actually use this URL to download this this dog photo like that. So we can just remove this print right now, and let's just save our file and run it once again. And as you can see, we saw this downloading bar, and here we have the photo of a dog. We will need these images to test our model once we fine tune it. Now let's just copy the next part. So in this case, down below it, we can also download one more image and save it under, let's say, cat.jpg file name. And here, so we will have, let's say, the dog photo and cat photo saved. If we run it once again, you will see that the new file should appear in this projects directory. Yeah, and as you can see now, we have both cat and dog photos here. So we will use them for, let's say, verifying or evaluating our model and how it works. Also pay attention to the fact that actually I just wrapped it inside of this download URL function. So here I just did it for the purpose of clarity, so you can see what kind of URL we are passing to this function, but here you can just wrap everything inside and it will have the same effect. Also, one more thing worth mentioning is that if you follow along the FastAI course, it may have some kind of, let's say, obsolete DuckDuckGo search version. So this should work at least if you are using Python 3.11.6 and you are doing this course somewhere at the beginning of 2024. But I cannot guarantee you as long as there will be no, let's say, breaking change in the nearest future. Once we have our photos for verification downloaded, now we can generate or actually look for the photos that we will use for building our let's say, training and validation database for our model. So in this case, as you can see, we have this piece of code from the article. So what's going on here? So as you can see here, we have this tuple with two searches. So we have dog and cat, and also we have this path. So we will create actually dog or cat a directory here in this main, let's say, projects directory, and then we are executing some kind of a for loop. So inside of the searches, we will look for both the dog and cat, and as you can see, if the directory doesn't exist, we will just create a new directory and then download and save those images under, let's say, a certain directory. So we will have both the, let's say, images of dogs and cats, and then also we will resize them. So like at least it will be one of the, let's say, dimensions will be 400 pixels. So it will take a bit less space. And what you can see here also on the line 30 and 31 is this kind of failed function. So some of the images may be corrupted. They may not be saved properly on our disk. So in this case, we don't want to pass this to the model. We don't want to keep this on our hard disk, so we will just actually remove those files, and also we will see actually control how many images were removed. So what we can do here right now is again execute this main.py file, and it may take a while. As you can see here, we will look for quite a few photos, both for cats and dogs. Right, so it looks like the fetching of the images has been finished, and you can see that two images were most likely corrupted. They were removed, and also we can see that the new directories were actually created. We can see some cat photos as well as dog photos. We will use this data for training our model, actually fine-tuning, and also for validating it. So as you can see here, we have this fine-tuning time right now. So we can just copy paste this, let's say, block of code. And what we can see here is this data loaders, DLS for abbreviation, some kind of probably. So in this function, actually we are preparing the data for our model before we execute this fine-tuning method on it. So we will use our blocks will be our images, and also we will categorize them by the type. So in this case, we will have this cats and dogs. As you can see, we have some kind of native functions that will just get the files from the path that we are passing here. So it will be, of course, this path that we can see here. So dog or cat path, actually this will be our directory with the files. And also we will label them based on this folder's names. And what else? We will also resize them once again. So please keep in mind that it will be just stored in the random access memory just for a while. We will use this method squish, which will actually squish the images. And here we could just stop and discuss it for a while. So if you are curious, you can look out for other methods. Actually, they have their own pros and cons. And our model will also need some kind of variety of different, say perspective, etc. And the method, the resizing, etc., can also have some kind of, let's say, later impact on the accuracy of the given model. However, let's move on. And with all of this code in place, we are almost done. Now what we can do is just add this learn variable here. So as you can see, we are just using this vision learner. So we will pass this data loader. So this will be our data of our images with labels, etc. So we will know which are cats, which photos are the images of cats, and which photos are the images of dogs. And then we will pass as a second argument, you can see this RESTnet18. Actually, this is a pre-trained model which will be downloaded from the internet, and you can use also different models. And as a third argument, we have this matrix, which will be our error rate, which we will see in a while. So it's not like we are creating the model from scratch or anything like that. It's rather just we are using the model that was kind of good, let's say, with recognizing different images, and now we'll just fine-tune it for our own particular case. So what we can do here is just add this fine-tune, execute actually fine-tune method on it. And you may be wondering, what is this number, this argument inside of this fine-tune method? And actually this is number of the epochs. So the more epochs you have, actually, let's say it will be like the recursion of, let's say, teaching model, or let's say fine-tuning the model with the data. However, it's not always good to increase it, let's say, to the maximum possible number, as it may, let's say, cause some kind of thing called over lifting. And also the same goes the other way around. So I think just for the purpose of this tutorial, 3 should be fine. And yeah, with that, we are almost done. We have just few lines more. So at this point, we have our model already fine-tuned. So what we can do as our last, let's say, point of this, let's say, coding part is just verify and, let's say, evaluate, can our, let's say, newly fine-tuned model really predict the images, let's say, based on their contents. So as you can see here, we have this tuple with predicted animal, prediction index, and prediction probability, and this is returned from the learn.predict, where we pass actually our dog image, and then we are just actually exchanging their values by defining them once again, but this time with cat. And also, as you can see, we have this some kind of a template literal. We can see what the given photo depicts, the probability of its content, and here we can see that it's actually some kind of an array. Actually, it's an array, let's say, list of tensors, and in our case we will have 2, so it will be a dog or cat. As you remember, we passed those cat and dog photos to our model, and also the most probable, let's say, result will be here returned as the second, let's say, parameter. So we can just pass this index here, as you can see, in those 2 places, and we can see the probability of, let's say, given result. And also we will just actually round it to the 4 places after the comma. So now with that, we can just execute our file once again. Let's run it. Okay, and that's done. As you can see, our model is already trained. We could see the epochs. In this case, we had those 3 epochs. They are valid, loss, error rate, etc. We can see that the error rate is actually 0, and here we have the 100% probability for dog being a dog and cat being a cat. So at this point, I would like to encourage you also to check out the FastAI course once again if you want to learn more about the details. And also feel free to play with this code, break it a little bit, extend it, build something else. Also pay attention that we didn't probably need to run all of this, let's say this code over and over again, just to re-download and just prepare this data. But it's of course, let's say up to you what kind of logic we would like to, let's say, implement here. And of course, in the next videos, I hope that we will create something even more complex. And yeah, as you can guess, probably we should now take this model somehow out of this, let's say, this environment, so that we can reuse it in various places. So that's all. Thank you for attention, and hopefully see you in the next video.